Okay, so now what we can do is we can have a look at all the steps we've got collected so far for factoring polynomials. So the first thing you want to do first is you want to use trial and error to find any and all possible integer zeros of p of x as possible. Okay, so that's using your remainder and factor theorems by substituting any integer in and seeing if it works. So it's kind of weird, but the first step is to use trial and error. Step 2 is to use the product and sum of zeros. Okay, so that is your stuff that we've just been doing in all of this one. And then if all else fails, use long division. Okay, so this is basically your checklist so far. I should write up here so far because we are actually going to be increasing on top of this. So always start off with your trial and error. Once you found one or two, because trial and error can take some time, use your sum and product rules, okay? If it's a quadratic and you found one of your roots, use a product and sum rule to find what the other one is. Okay, if it's a quadratic, if it's a cubic, find two. Okay, or if you found one, you can use simultaneous equations to find the second one, okay? So it's up to you in that regard. So what we're going to be doing is we're actually going to have a look at an example of factorizing this using some of the methods we picked up so far. So we're going to start off with this equation, or this polynomial here. So we're going to factor f of x is equal to x power 4 plus x cubed minus 9x squared plus 11x minus 4 completely. So what we're going to do is we're going to start off with the first part, which was to find any, or use trial and error to find any of the points so far. So let's try some points, okay? And the points I'm going to try are magically going to work, by the way. So let's try 1. So 1 cubed minus 9 lots of 1 squared plus 11 lots of 1 minus 4. So f of 1 is equal to, okay, so we're going to put this one into our calculator. So it's 1 to the power of 4 plus 1 cubed minus 9 lots of 1 squared plus 11 lots of 1 minus 4, which is equal to 0, okay? So therefore, x minus 1 is a factor. Or I should say x is equal to 1 as a factor. Okay, let's try another one. Let's try f of, I don't know, minus 4. Okay, remembering that all of the factors are going to have to be factors of this guy here. So 1 and minus 4, 2 and minus 2, and minus 1 and 4. So those are all going to be your factors. Okay. Well, the possible factors, I should say. So minus 4 is equal to, so substitute it in, minus 4 to the power of 4 plus minus 4 cubed minus 9 lots of minus 4 squared plus 11 lots of minus 4 minus 4. Okay, so putting that one in, this is why I like using the calculator, because you can just quickly change the values that you want. Okay, and this is why I tell people to use brackets as well, because you can literally see which number needs to be replaced. Okay, like that. Hit equals, oh, look at that. It's equal to 0, 2. So therefore, x is equal to 4. Oops. X is equal to minus 4 is a factor. Okay. So now that we've got that, what we can do is we can say, well, let's let the zeros be 1 minus 4, which we know, and alpha and beta, the ones that we don't know. And so once we've got these, what we can do is we can actually work out some equations. So then the sum of the zeros is equal to, well, in this case, it's the, so the sum is the last one, so the minus 4 over the original, so it's minus 4 over 1, which is minus 4. And we can also say that the sum of these, so times by 1 times by minus 4, is equal to Oh, wait, sorry. Oh, God, it's not minus 4 up here. It should be the negative of the first, so it's minus 1 over 1, so it's equal to minus 1. That makes it a bit more easier. And so then the product should be equal to the second one over the first, the last one over the first one, so that's minus 4 over 1, so it's minus 4, okay? So we end up with these two equations. We get alpha plus beta plus 1 minus 4 is equal to minus 1. Okay, so rearranging this, we're going to get alpha plus beta is equal to 2, which we'll call equation 1. And we get this second equation, which is minus 4 alpha beta is equal to minus 4. So alpha beta is equal to 1, which we'll call equation 2. Now to find our other roots. So remember, like before, when we rearrange these and substitute it in, it will give us both the roots just from one of them, because the other one just gives you the opposites of them. So what we're going to do is we're going to rearrange it. So we get alpha is equal to 2 minus b, sub into equation number 2. So that is alpha beta is equal to 1. So 2 minus beta, lots of beta, is equal to 1. Okay, so that's 2 beta minus beta squared is equal to 1. Or in other words, 0 is equal to beta squared minus 2 beta plus 1. Now, just finding the quick roots of these, we should get beta is minus 1 and beta is minus 1. So beta minus 1 squared. So therefore, beta is equal to 1 is a double root. Okay, and we can see that that is the case of both of these equations. So if I quickly go back up to my original equations, 1 plus 1 is equal to 2, and 1 times 1 is equal to 1. So it must be a double root there. Okay. So I'm going to leave it at that, and that is my double roots there. So therefore, what we can do is we can now write this as in factored form. So f of x is equal to x to the power of 4 plus x cubed minus 9x squared plus 11x minus 4, okay, is equal to, so we've got the double root, so it's going to be x minus 1 all squared, and then we've got the other values, so it's going to be our other roots, which we guessed before, which was x minus 1 again, I think, actually, so it should be a triple root on that. So where were my roots? So the zeros are 1 minus 4, so no, it's going to be if it's double roots, oh hang on, I'm just trying to get my head around it. Yeah, no, it is going to be a triple root, so it should, x minus 1 is the other one, and x plus 4 is the other, because they need to be equal to 0, so x is equal to minus 4, yep. So that means we get x minus 1 cubed and x plus 4 for the second one. And so that is our fully factored form for that one. So quite a bit of work to fully factorize it, but I mean, we can do it now. We can factorize a quartic equation, which is what that one is. Now let's have another quick look at an example at another one. Let's have a quick look at another example. Now, if 1, 0 of the cubic is the opposite of other, prove that AD is equal to BC. So we know that 1, 0 is the opposite of the other. So the following sentences express this symbolically. So let's let, I'm going to zoom in, let the zeros be alpha and minus alpha and beta. Okay, we know this because this one is the opposite of this one. That's kind of weird. I'm going to have to get used to that. So alpha minus alpha. So alpha minus alpha. Those are opposites of each other. I don't know why I did that. Okay, and then we've got our third root there, just finding out which is the beta. So what we can do now is we can actually use our formula for the sum of the roots. So the sum of the roots, alpha plus beta plus gamma, is equal to, in this case, it is minus b over a. Okay, but we know that in this case, our gamma is actually equal to minus alpha. So that's equal to minus b on a. So alpha minus alpha, well, those two are going to cancel out. It's going to leave us with beta is equal to minus b on a. Okay, so pretty easy. Okay, and then rearranging this, we get minus b is equal to a lots of beta, just like that. Okay, now we're going to use the formula for the product of the roots. So the product of the roots. So the product of the roots, what we're going to do is we're going to let, so we've got a, or not a, sorry, so the product, oh, for God's sakes. The product is alpha times beta times gamma is equal to, in this case, it's going to be minus d on a, okay? So in remembering that gamma, in this case, is a second alpha, it's just the opposite, so it's going to be alpha times beta times negative alpha, which is equal to negative d on a. Okay, alpha times alpha, or negative alpha, is negative alpha squared, with the beta sitting there too. That's equal to minus d on a. And what we can do is we can remove the negatives from both, so we get a squared plus alpha squared plus beta is equal to d on a. Okay, and then removing the a together, so we get a alpha squared beta is equal to d, just like that. Okay, and we're going to call these ones equation 1 and equation 2. Now these are three products of pairs of roots, namely a or minus a squared these are three products of pairs of roots. So we can, like, I'm getting my words muddled up. What we can do now is we can find the three products of pairs of roots, okay? So we can do minus alpha squared, minus alpha beta, and we can do alpha beta, okay? And so using that rule, we get minus alpha squared minus alpha beta plus beta alpha, I guess if you will, over C of A, or C over A is equal to C over A. Okay, so we've got minus alpha beta and plus alpha beta, so those two are going to disappear. It's going to leave us with minus alpha squared is equal to C over A. So minus A lots of alpha squared is equal to C. And so there we go, we've got our three terms. Okay. Now, what we're going to do is we can solve these three terms simultaneously. Okay, so what we can do is we can push these all together to try and get them to be equal to something. So the way we're going to do this is we're going to take, we're going to combine these three identities by doing 1 times 3 divided by 2. Or in other words, we're going to do alpha beta times, not alpha beta, we're going to do, so the first equation, we'll take this equation here, so minus b. So we're going to take, well, I'll write it like this, minus b times minus c over d, which is equal to, so back up here, original things, alpha beta, or a beta times a alpha squared over a alpha squared beta. Okay, and that's equal to minus b times c over d. Okay, which is the same as having, so this guy on the left, so is our a value. So if we were to substitute these values in, that would be equal to a, because if you work this out, okay, b alpha squared and alpha squared b, and it leaves you with the a term. Okay, so a is equal to minus b times minus c, which is bc over d. So that means that AD is equal to BC, like that, and that is what we need. So that one was really tricky, actually, and you won't be needing a question like that, like, very often, where you need to really identify your polynomial and stuff. It's more of an extension to style of question and just saying that we can isolate an A value, okay, by using a combination of these three different things. So with that being said, that's going to be the end of this video and the end for this part. I'm going to leave it there, and we're going to talk about the multiple zeros in the next one. So I'll talk to you then.